storm, or with microbits, again, connected to the physical world. But also to do more things just interacting with the computer. So you can see we're working with Google to use some of their speech recognition technology, and you can add those blocks into Scratch. So there'll be some new blocks, both for speech synthesis, for speaking. So I can say, speak hello, and then the program will actually talk. We won't just have a voice balloon, like in the current version of Scratch. You'll actually have a voice that comes out, and you can set what the voice sounds like. And there'll also be voice speech recognition. So you can say, when I hear a certain word, then I should say something. So just as a little example here, in this project, it says here, it says, when I hear, what time is it? Then the program should say, it's party time. So this is just a simulation of it. It's not really running right now. But it should work by saying, what time is it? Oops, didn't work. I'll try it again. What time is it? So there it's. So to recognize, so basically children could make programs that respond to voice commands. And again, I think this is what we're always trying to do, that there's many new devices now that you can talk to. So children will grow up in a world where they can't interact with technology through their voice. But it will seem magical to them. And we're often looking, when children have a certain way of interacting with technology, we want to give them the power to create their own projects using those same approaches. So if children are interacting with technology through their voice, they should be able to create their own projects to respond to voice commands. So that's what we're adding to Scratch. We're also, we know that many children now, when they play games, like the Nintendo Wii, they can just make gestures with their hands to control things on the screen. So with many games now, you're not just at the keyboard or even with the joystick. You can make different ways of, different controllers. You act at a distance to communicate with the game. So we want to do the same thing with Scratch. So we're developing a new piece of hardware that's called the Scratch Bits. That will communicate with your Scratch project wirelessly. So you can now create a Scratch project, and then also create your own interface that interacts with your Scratch project. So let me show you an example. Hopefully this will work. This is still a prototype. So let's see, I'll put this full screen for a moment. And there's a green flag button on here. So I can start it by hitting the green flag button, I hope. Let's see why it's not working. Okay. So you notice, as I tilt this, the bicycle moves one way or the other. And I can try to capture balloons. There's a tilt sensor, an accelerometer here, so I can move this. And notice, this is what a child can do. Since they made a program about a bicycle, a game about a bicycle, handlebars, they actually built bicycle handlebars with Lego. So we want children not just do the joystick, but to build things in the physical world as well. They also programmed it so when I hit the button, it plays a horn. But again, children can decide what they build, what their interface should look like, and then what the different features should be, what the button should do. There's a light sensor. What happens with the light sensor? What happens? I think I get extra points if I get to Taka. I think it's keeping score there. Each time I get a balloon. And you can look at the code. The code says this code that has things like, it says what is the tilt angle? So it's tilted one way, the graphic should go one way. When it's tilted the other way, it goes the other way. When the button is pressed, it plays a sound. Let me show one more example. This one, rather than a game, it's a story. Actually, let me make it full screen again.